Well, the key to this problem is breaking it into parts. And this question really has two parts the way I see it. First, we have an energy part. When I squeeze the spring, I'm adding elastic potential energy into our system. When I let this go and release it, well, that elastic potential energy is being converted to kinetic energy. And so from that, I should be able to find the velocity at which the mass leaves the table. How do I do that? Well, I say that all of the potential energy, and this is the potential energy in a spring, well, it all gets converted to kinetic energy. And solving out the algebra, which I've done in a few steps here, tells me that the velocity with which it leaves the spring and therefore leaves the table is equal to x times the square root of k over m. Plugging in our values, well, x is 0.25 centimeters, remember, not meters, times the square root of 350 over 1, but over 1 doesn't change anything, so square root of 350. And this gives me a velocity of 4.68 meters per second. Okay, phase 1 of the problem is done. Now we can just think of this problem as a block being thrown horizontally with a velocity of 4.68 meters per second. And now we use our standard two-dimensional motion skills to solve this. Well, first I want to calculate the time spent in the air. Since there's no vertical velocity initially, my equation of motion simplifies to this. There's no v0t term this time. I know delta y is equal to h, so manipulating this around, moving the 2 up, dividing by g, I find t squared is equal to 2h over g, which means the time the object spends in the air is just the square root of that. 2 times h is 2 meters, so 2 times 2 is 4, over g, which is 10, gives me a time of 0.63 seconds. And now, well, I'm almost done. We know that vertical and horizontal motion are independent in free fall. And we're moving at this constant velocity of 4.68 meters per second horizontally for 0.63 seconds. So d is just equal to this v, well, I'll call it 0x now, the initial velocity in the x direction, times this time. And when I plug in these numbers, I get a distance of 2.96, or we'll just round it to 3 meters.